In this lesson, we're going to go over function operations and composition. So we're going to perform various operations on functions, including composition, and then we're going to use composition of functions to model real-world situations. So first thing we should do is just kind of recap functions in general. So given that you have two functions, f of x and g of x, find each value. So if we want to find f of 7, I have to use the f function, and I'm going to plug in 7 every time I see an x. So f of 7 is going to equal -4 times 7 plus 3. So this is going to be -28 plus 3, and I end up with -25. Okay, in the second one, we're doing g of -1/2. So this time we have to use the g function, and similar to the other one, we're going to plug in -1/2 every time we see an x. So -1/2 goes in for x. 1/2 times -1/2 is going to give me -1/4, and then -3. In order to subtract this, I need a common denominator. So 4 would be my common denominator. So right now this 3 has a denominator of 1, so I can multiply it by 4 on the top and bottom. So this will give me 12 over 4. And then now that they have common denominators, I can just combine the numerators together. So this gives me -13 over 4. And then for this last problem, f of 6 minus g of 4. So we're going to have to first find f of 6. So we're using the f function, and we'll plug in 6 for x. So this is going to give me -24 plus 3, which is going to give me -21. I then have to find g of 4. So I'm using the g function, and I'm plugging 4 in for x. So this is going to give me 1/2 times 4 is 2, minus 3 is -1. So for f of 6 minus g of 4, that's going to be -21 minus -1, so -21 plus 1, which is going to give me -20. So first we're going to look at function operations. So we have addition, subtraction, multiplication, and division, and you can see the two different ways that they're written. So sometimes you'll see f plus g of x, but that's the same thing as saying f of x plus g of x. Same thing for subtraction, multiplication, and division. You can break it up into the f of one function plus the other function, or minus, or multiplying, or dividing. With division, we want to make note that the denominator can't equal 0, because then that would be undefined. So we can never have 0 in the denominator of our fraction. And then, so let's look at this example. So for A, here we have f plus g of f plus g of x. So with this x here on the outside, these x's on the outside don't mean that you're going to multiply your answer by x. It's just saying that the variable that we're using is x. So f plus g of x means that we're going to have f of x plus g of x. So we take our f of x function, which is 5x minus 6, and we're going to add that to our g of x function, which is x squared minus 5x plus 6. From here, we're just going to combine like terms. So I always like to start with the highest exponent. So I have an x squared here, and no other x squared, so I'm going to have x squared. I have a 5x and a -5x, so these are going to cancel out. And I have a -6 and a +6, which will also cancel out. So our answer here is just x squared. In the second example, f minus g of x, we're just going to take f of x minus g of x. So our f of x function is 5x minus 6. Our g of x function is x squared minus 5x plus 6. Because we're subtracting, we want to make sure that we distribute this negative to everything that comes after it. So if I drop the parentheses, this is going to be 5x minus 6, and then if I distribute, this is going to be -x squared, this is going to be positive 5x, and then lastly we'll have -6. So we're going to combine like terms, and I'm just going to put this into standard form, which means I'm starting with the highest exponent. So my highest exponent is x squared. I don't have any other ones, so I have negative x squared. I have a 5x and a 5x, so that'll give me 10x. And then I have a negative 6 and a negative 6, so I have a negative 12. So now that would be my answer. Okay, and then we're going to look at multiplication and division. So same idea, f times g of x, that's going to be f of x times g of x. So our f of x function is x plus 2. Our g of x function is x squared minus 4. So we have to just FOIL this together. So if we FOIL this, x times x squared, that's going to give me x to the third. X times negative 4, negative 4x. 2 times x squared is 2x squared. And 2 times negative 4 is negative 8. So I'm just going to put this in standard form. So I'm going to put them in order of their highest exponents. So x cubed, and then plus 2x squared, minus 4x, minus 8. Okay, and then our last example here, g over f of x. So we're going to have g of x over f of x. So our g of x function is x squared minus 4. Our f of x function is x plus 2. X squared minus 4 can be factored, and we are going to go through factoring again later on, but hopefully you know how to factor this one. So this will become x plus 2, x minus 2. That's difference of squares. And then we have x plus 2 in the bottom. And we can cancel out the x plus 2's. They reduce. So we're just left with x minus 2 as our answer. And because we had something in the denominator, we have to make sure that we state along with our answer what x can't be. So x can't be negative 2 because that made the original denominator equal to 0. So we're just going to tack that on as well.